On October 7th, 1959, a small Soviet spacecraft swung behind the moon, pointed a camera at a surface no human eye had ever seen, and took 17 photographs. When the images came back to Earth, the scientists in the room went quiet. Because the back of the moon, the side that had been hidden from every astronomer in human history, from Galileo to Hubble, did not look like the front. It looked, in the words of one Soviet astronomer, like a different moon. This is a video about that other moon, the one you have never seen, the one almost everything you have been told about, starting with its name, is wrong about, and the one that, in the next 20 years, is going to become the most fought over real estate in the solar system. Let me start by breaking something. The dark side of the moon is not dark. It is not in shadow. It is not frozen. It is not sunless. Right now, as you watch this, half of the far side is in full sunlight, the same sunlight that hits the Sahara at noon. Over the course of a month, the far side receives almost exactly the same amount of solar energy as the side you see every night. The two sides take turns. They always have. So why does everyone call it dark? Because in the 19th century, when the phrase entered English, dark did not mean without light. It meant without knowledge. Darkest Africa, a dark secret. The Dark Ages. The dark side of the moon meant the side we could not see, the side that was dark to us, the side that was unknown. Then, in 1973, Pink Floyd released an album, and the meaning of the phrase changed forever. For most people now, dark side of the moon sounds like a description of a place. It is not. It is a description of our ignorance. And here is the part that should make you uncomfortable. We are still ignorant. We have photographed the far side from orbit. We have landed on it exactly once in human history, a Chinese spacecraft in 2019. We have brought back samples from it exactly once, also Chinese in 2024. Everything we know about half of the nearest object to Earth has been learned in the last 67 years, and most of it in the last 6. The far side is not dark, but it is still, in the original sense of the word, the darkest place we know. I am going to tell you 3 things in this video that will change how you think about the moon. The first is what is actually on the back of it, and why it looks nothing like the front. The second is what is buried underneath it, a mass anomaly the size of Hawaii, sitting hundreds of kilometers below the surface that nobody can fully explain. The third is why, in the next 20 years, the far side will become the most contested territory in the solar system, and almost no one is paying attention. Let's start with how we figured out we were only ever seeing half. In 1693, a French-Italian astronomer named Giovanni Domenico Cassini was sitting in the Paris Observatory, doing something nobody had done before. He was measuring the moon, not its distance, not its size, its face. For decades, Cassini had been watching the moon through one of the best telescopes in Europe, and he had noticed something strange. The features on the moon's surface, the craters, the dark plains, the bright highlands, never moved. Or rather, they almost never moved. They wobbled slightly around the edges, but the central features stayed where they were, month after month, year after year, decade after decade. This should not have been possible. Every object that rotates when seen from a distance shows you all of its sides over time. Spin a globe in front of you. You see Europe, then Asia, then the Pacific, then the Americas, then Europe again. The moon, Cassini realized, was not doing this. The moon was rotating. He could prove that, but it was rotating at exactly the same rate that it orbited the Earth. Every time it went a quarter of the way around us, it turned a quarter of the way on its axis. The result was that the same face was always pointed at Earth. This is called tidal locking. And the fact that Cassini figured it out with a telescope made of brass and glass 330 years ago is one of the most underrated achievements in the history of astronomy. But Cassini could not explain why the moon was locked. That answer would not come for another 2 centuries. Here is what we now know. When the moon first formed, around 4.5 billion years ago, it was much closer to the Earth and rotating much faster. A day on the moon may have been only a few hours long. The Earth's gravity pulling on the moon was not perfectly even. It pulled harder on the near side than the far side. That uneven pull deformed the moon. It stretched it very slightly into an egg shape with one pointed end facing Earth. And then the moon kept rotating. Every time it tried to spin past the lock position, the Earth's gravity pulled it back. The friction of that constant pulling slowed the moon down. Over hundreds of millions of years, the moon's rotation slowed and slowed until it matched its orbit. At that point, the egg shape stopped being dragged. It locked into place, and the moon has been pointed at us with one face ever since. There is a strange consequence of this that almost nobody talks about. The same process is happening to Earth. The moon is slowing down the Earth's rotation by about 1.7 milliseconds per century. It is also moving away from us, about 3.8 centimeters per year, measured by lasers bounced off mirrors the Apollo astronauts left behind. Hundreds of millions of years from now, if the Earth and Moon survive that long, the Earth will be tidally locked to the Moon too. The day will be the same length as the month. The Moon will hang motionless in the sky, visible from one hemisphere and invisible from the other. We are halfway through a process that started before there was life on Earth and will end after most life is gone. But Cassini, in 1693, did not know any of this. He just knew that the moon was hiding something, and he knew that no human being would ever see what was on the other side. He was right for another 266 years. The first human to see the far side of the moon was not an astronaut. He was a Soviet astronomer named Nikolai Barabashov, and he saw it on a desk in Kharkov, Ukraine, in October 1959, on a stack of grainy photographs that had been radio transmitted from a spacecraft that no longer existed. Luna 3 was small, about the size of a refrigerator. It had been launched on October 4th, 1959, 2 years to the day after Sputnik, and it had been built around a single objective: swing behind the moon, take pictures of the side nobody had ever seen, send them home. The camera system was strange by modern standards. There was no digital sensor. The spacecraft carried a small reel of 35mm film, which it exposed to the lunar surface as it passed by, then developed on board in flight using an automated chemical bath. Then it scanned the developed negatives with a light beam and transmitted the brightness values back to Earth over radio. The whole apparatus had to work, in sequence, perfectly, on a spacecraft that nobody could repair if it failed. It mostly worked. 17 of the 29 planned photographs came through. The rest were lost, corrupted by radiation, lost to transmission errors, or simply too faint to recover. The 17 that survived were grainy, low contrast, and partially obscured. By modern standards, they are almost unreadable. But in October 1959, they were the most valuable images in the history of astronomy. Nikolai Barabashov was the man tasked with interpreting them. He was the director of the Kharkov Observatory, one of the Soviet Union's leading lunar specialists, and he was given the photographs and asked to produce a map. What he saw confused him. The near side of the moon, the side every human being had ever seen, is dominated by dark plains. Astronomers call them Maria, Latin for seas, because early observers thought they were oceans. They are not. They are vast pools of solidified lava, formed when ancient impact basins were flooded by magma from the moon's interior, billions of years ago. The Maria are why the moon has a face. The man in the moon, the rabbit in the moon, the woman with the basket, all of them are pareidolia produced by the dark patterns of the Maria against the bright lunar highlands. Barabashov looked at the 17 photographs of the far side, and the Maria were gone. Not reduced, not different. Gone. The far side in the photographs was almost entirely highlands, cratered, ancient, bright terrain, with only the faintest traces of dark plains in a few small spots. The face was missing. The moon had a face on one side and a wall of craters on the other. This should not have been possible. The moon in 1959 was assumed to be roughly symmetric. The two sides had formed at the same time from the same material and had spent 4.5 billion years sitting in the same orbit, exposed to the same impacts, cooling at the same rate. They should have looked the same. They did not look the same. They looked like two different worlds. Barabashov and his team produced the first atlas of the far side in 1960. It was a triumph of Soviet science. It named features: the Sea of Moscow, the Sea of Dreams, craters for Tsiolkovsky and Lomonosov, and Jules Verne. Many of those names are still on lunar maps today. But the deeper question, why are the two sides different, was not answered. It would not be answered for 60 years. In some ways, it has still not been answered. This is the first of the three things I promised you. The far side does not look like the near side, and the reason why is one of the great open mysteries of planetary science. Here is what we know. The far side crust is thicker, in some places by 20 kilometers or more. The near side crust averages about 50 kilometers thick. The far side averages closer to 70. That is not a small difference. That is one side of the same world having 40% more crust than the other. The far side is more heavily cratered, by a factor of about 2. Every crater you see on the far side is a record of an impact, preserved because nothing came along to erase it. The near side was repaved by lava. The far side was not. The far side has almost no volcanic plains. The Maria that dominate the near side cover 1% of the far side, a few small pools, nothing more. And the far side contains the largest impact crater in the inner solar system. It is called the South Pole-Aitken Basin. It is 2,500 kilometers across, large enough that if you laid it across the United States, it would stretch from New York to Las Vegas. It is 13 kilometers deep at its deepest point. It is so old that nobody is certain when it formed, though the best estimates put it at around 4.3 billion years ago, almost as old as the moon itself. And buried beneath the floor of that basin, 400 kilometers down, is something that nobody can fully explain. We will come back to that. The asymmetry of the moon is one of those problems that sounds simple and turns out to be one of the hardest questions in planetary science. Two sides of the same body, same age, same orbit, same material. Why are they different? There are 4 serious answers. None of them is fully accepted. All of them are partially supported. The truth is probably some combination. The first answer is tidal heating. When the moon was forming, the Earth was very close, and the Earth was very hot. The near side of the moon, the side that always faced Earth, would have been bathed in heat radiation from the molten Earth for tens of millions of years. The far side, facing away, would have cooled faster. A faster cooling far side would have produced a thicker crust. A slower cooling near side would have stayed molten longer, allowing magma to break through more easily later in lunar history. This works mathematically, partially. The temperature differences are real, but they are not large enough to fully explain the crustal asymmetry we observe. They are part of the answer, not the whole answer. The second answer is the two-moon hypothesis. In 2011, two planetary scientists named Martin Utzi and Eric Asfaug proposed something strange. What if, when the moon formed, it didn't form alone? What if there were two moons? A large one and a small one formed from the same debris disk after the giant impact that created the moon, orbiting Earth alongside each other for tens of millions of years. In their simulation, the two moons eventually collided, but not catastrophically. The smaller moon, about 1,200 kilometers across, approached the larger moon at low velocity and splattered onto the far side. It didn't shatter the moon, it accreted onto it. It added an extra layer of crust to one hemisphere. This explains the thicker far side crust. It explains the asymmetry. It explains why the additional material is on the far side specifically, because the smaller moon was orbiting in a stable point that faced away from Earth. It is an elegant hypothesis. It is also currently impossible to confirm. Confirming it would require samples from deep in the far side crust, which we do not yet have. The third answer is the South Pole-Aitken impact. When the South Pole-Aitken basin formed, around 4.3 billion years ago, it released an amount of energy that is genuinely difficult to comprehend. The object that hit the moon was probably 200 kilometers across. The impact gouged a hole that went, in places, all the way down into the lunar mantle. It melted vast quantities of rock. It threw debris across the entire surface of the moon. And, according to recent simulations, it may have redistributed heat-producing radioactive elements within the moon's interior, concentrating them on the near side. If that is true, then the near side, billions of years after the impact, was generating more internal heat than the far side. More heat meant more magma. More magma meant more volcanic activity. More volcanic activity meant the lava flows that filled the Maria and gave the near side its face. The South Pole-Aitken impact in this model is the reason the near side has a face at all. The fourth answer is that we don't fully know. This is the honest answer, and it is the one most planetary scientists would give you if you asked them at a conference rather than on television. The asymmetry of the moon is an unsolved problem. The hypotheses above are all plausible. The data is incomplete. The samples we need are on a part of the moon we have barely touched. This is why, in June 2024, China did something nobody else has ever done. On June 25th, 2024, a Chinese spacecraft called Chang'e 6 landed in the Earth's Pacific Ocean, carrying 1.9 kilograms of lunar soil. It was the first material ever returned from the far side of the moon. To understand how hard this was, you have to understand why nobody else had done it. Landing on the far side is not just a matter of pointing a spacecraft at the moon and firing the rockets. The body of the moon, when you are on the far side, blocks all direct communication with Earth. Your spacecraft cannot talk to mission control. Mission control cannot talk to your spacecraft. You are operating for the duration of your time on the surface, completely out of contact. This is not a problem you can solve by waiting. Earth never rises on the far side. There is no orbital geometry, no time of day, no season in which the body of the moon stops being between your spacecraft and your home planet. If you want to talk to a lander on the far side, you need a relay satellite, a separate spacecraft parked in a specific orbit that can see your lander on one side and Earth on the other at the same time. China launched that relay satellite Quietest in 2018. The name means magpie bridge, from a Chinese folktale in which magpies form a bridge across the Milky Way once a year so that two separated lovers can meet. It is sitting right now at a gravitational balance point beyond the moon called the Earth-Moon L, to Lagrange point, where it can hover with minimal fuel and see both worlds at once. Quietest made Chang'e 4 possible, China's first far-side lander, which touched down in January 2019. Quietest made Chang'e 6 possible, and in 2024, China launched a second, more advanced relay, Quietest 2, specifically to support the sample return mission. Without those satellites, the far side might as well be on another planet. Chang'e 6 landed in a smaller crater called Apollo, which sits on the floor of the South Pole-Aitken basin. Apollo was chosen for a specific reason. The South Pole-Aitken impact billions of years ago excavated material from deep inside the moon, possibly from the lunar mantle itself. That material is sitting on the surface of the basin floor. A spacecraft that lands there does not have to drill. It just has to scoop. Chang'e 6 scooped. It drilled a little to get samples from about 2 meters down. It collected 1.9 kilograms of material. It launched a small ascent vehicle from the lunar surface, rendezvoused with an orbiter, transferred the samples, and sent them home. The samples landed in Inner Mongolia on June 25, 2024. The analysis is ongoing. But what has already been published is rewriting parts of lunar science. The Chang'e 6 samples contain volcanic basalt that is approximately 2.8 billion years old. That number is important. Until 2024, the prevailing model was that volcanic activity on the far side had effectively ended billions of years before that the thick far side crust had shut down magma flow early in lunar history. The Chang'e 6 samples show that this is wrong. Volcanism continued on the far side for much longer than we thought. There was lava flowing in the South Pole-Aitken basin at a time when, on Earth, the first complex single-celled organisms were appearing in the oceans. The samples also show a different chemical signature than near-side basalts. Less of certain elements, more of others. The implications are still being worked out, but the early consensus is that the lunar mantle on the far side is genuinely different from the lunar mantle on the near side. The two hemispheres of the moon are not just different on the surface, they are different all the way down. This is the kind of result that takes a decade to fully integrate. Every paper that comes out from this material is, in some real sense, the first time humanity has learned something specific about the inside of the back of the moon. And there is more coming. China has announced Chang'e 7 for the lunar South Pole, Chang'e 8 as a precursor to a permanent base. The United States, through the Artemis program, is targeting the South Pole as well, a region that overlaps geographically with the southern rim of the South Pole-Aitken basin. India, Japan, Russia, and the European Space Agency all have far side ambitions. The age of looking at the far side from orbit is over. The age of touching it has begun. Which brings us back to the thing buried under the basin. In 2019, a team of geophysicists at Baylor University published a paper that caused a brief flurry of headlines and then mostly disappeared from public attention. They had been analyzing gravity data from NASA's Grail mission, twin spacecraft that orbited the moon in 2012 and mapped its gravitational field at higher resolution than any previous mission. Grail worked by measuring tiny changes in the distance between the two spacecraft. When one spacecraft passed over a region of denser than average rock, it sped up slightly. When it passed over a region of less dense rock, it slowed down. The variations were measured in micrometers per second. They produced the most detailed gravity map of any world other than Earth. What the Baylor team found, buried 400 kilometers beneath the floor of the South Pole-Aitken basin, was a mass. A large mass. Approximately 2.18 quintillion kilograms of something sitting beneath the basin floor, pulling on the gravity field hard enough to deform the entire basin shape. The anomaly is roughly 300 kilometers across. It is dense enough to suggest it is made of metal-rich rock, possibly iron and nickel, possibly something else. There are two leading hypotheses for what it is. The first is that it is the asteroid, the object that gouged out the South Pole-Aitken basin 4.3 billion years ago, may have been so large and so dense that its core punched through the lunar crust and embedded itself in the mantle. The impact in this scenario did not destroy the asteroid. It buried it. The core of an object the size of a small moon may still be sitting there, slowly cooling, beneath kilometers of shattered lunar rock. The second hypothesis is that the anomaly is a concentration of dense oxide minerals, leftover material from the very last stages of the lunar magma ocean, when the moon's surface was still molten and the heaviest elements were sinking to the bottom. In this scenario, the South Pole-Aitken impact didn't bury a foreign object. It punched a hole down to a layer of naturally concentrated, dense material that had been there all along. The data does not yet distinguish between these possibilities. Both are consistent with what we observe. The difference matters enormously. If the anomaly is the remnant asteroid, it is a fossilized piece of the early solar system, preserved on the moon, accessible to future missions. If it is a concentration of native lunar material, it tells us something profound about how the moon's interior is structured, and possibly about how all rocky planets differentiate. Either way, it is sitting there right now, 400 kilometers below a surface that no human has ever walked on, waiting. This is the second thing I promised you. There is something buried in the moon that we cannot yet explain. The first humans to land near the South Pole-Aitken basin, and they are coming in this decade or the next, will be standing on top of one of the most important geological mysteries in the inner solar system. There is one more thing about the far side that almost nobody talks about, because the people who care about it are radio astronomers, and radio astronomers are not famous. The far side of the moon is the quietest place in the inner solar system, radio quietest specifically. Earth is loud. Every transmission from every human source, every cell phone, every television tower, every GPS satellite, every Wi-Fi router, every microwave oven leaking faint emissions, every spark from every machine ever built produces radio waves. Those waves fill the sky. They fill low Earth orbit. They drown out the faint signals from the early universe. The moon blocks all of it. When you stand on the far side, 3,475 kilometers of solid rock sit between you and every transmitter on Earth. The radio sky goes silent. The cosmic background becomes audible, and signals that have never been detected from anywhere else in the solar system, signals from the first 400 million years of the universe, from the era before the first stars lit up, become for the first time observable. Astronomers call this period the cosmic dark ages. It is the longest stretch of cosmic history we know almost nothing about. It is the time between the Big Bang's afterglow and the first stars, when the universe was filled with neutral hydrogen and very little else. The hydrogen during this period emitted a faint radio signal at a specific frequency. That signal has been redshifted by the expansion of the universe into a band of frequencies that, on Earth, is buried beneath FM radio. You cannot detect it from Earth. You cannot detect it from low Earth orbit. You cannot detect it from the near side of the moon, because the Earth is hanging in the sky right above you, blasting radio noise in every direction. You can detect it from the far side. This is not theoretical. Multiple space agencies have funded designs for far-side radio telescopes. NASA's Lunar Crater radio telescope concept would deploy a 1-kilometer-wide wire mesh inside a natural lunar crater, using the crater itself as the dish. The Chinese already deployed a small low-frequency antenna on the far side, attached to a relay satellite, as part of the Chang'e 4 mission. The European Space Agency has its own proposals. The Netherlands' China Low-Frequency Explorer flew on Queqiao and made the first low-frequency radio observations from lunar orbit. The far side is, in the assessment of radio astronomers worldwide, the most valuable piece of scientific real estate in the inner solar system. And there is a problem. The same property that makes the far side valuable to astronomers makes it valuable to everyone else. The lunar South Pole, where Chang'e 7, Chang'e 8, the Artemis program, and several commercial ventures are all targeting, sits at the southern edge of the South Pole-Aitken basin. The far side and the South Pole overlap. Every rover, every lander, every relay satellite, every base, every communications link is a source of radio interference. If enough machines start operating on or near the far side, it stops being quiet. The window of opportunity to build the kind of pristine far-side radio observatory that astronomers have been dreaming of since the 1960s is, in their estimation, 20 years. Maybe less. The decisions made in the next decade about who is allowed to put what near the far side will determine whether humanity gets to listen to the first stars or whether we drown them out before we hear them. This is the third thing I promised you. The far side is about to become the most contested territory in the solar system, and the contest is happening right now, mostly out of public view. The Artemis Accords, signed by the United States and a growing coalition of allies, govern one framework for lunar activity. The International Lunar Research Station, led by China and Russia, governs another. Neither framework fully addresses radio quiet zones. Neither has the enforcement capacity to monitor far side activity in real time. The far side is the first frontier in human history where the entire territory is invisible to everyone except the people who are there. Anything that happens on the far side happens out of sight. Before we get to the end, let me clear out some debris. Because for as long as humans have known there was a side of the moon we couldn't see, humans have been filling it with things that aren't there. There is no Nazi base on the far side. This one started in the 1950s and has cycled through every decade of conspiracy media since. It is not true. There is no alien installation on the far side. We have photographed every square kilometer of the surface at resolutions down to 0.5 meters per pixel, from at least 5 independent national space programs. There are no structures. There are no spires. There are no geometric formations that cannot be explained by ordinary geology. We have looked. There is nothing there but rock. There is no permanent shadow on the far side. The far side receives the same sunlight as the near side on a half-month offset. Half of it is illuminated right now. The Apollo astronauts did not land on the far side. All 6 Apollo landings were on the near side. The far side has been touched by exactly one country in human history. That country is China. The Pink Floyd album is not about the moon. Roger Waters has said this repeatedly. The dark side in the title is a metaphor for the human mind. The album cover is a prism, not a planet. The title borrowed a phrase that was already a misconception and used it as a metaphor for a different kind of darkness. And the moon is not, in any sense, hollow. It is not a spacecraft. It is not artificial. It rings when struck by impacts because it is a dry, dense, solid body with very little water to dampen seismic waves. The Apollo seismometers heard this. It is a mundane consequence of lunar geology, not evidence of a constructed object. I am telling you all of this not to be condescending, but because the far side has spent 400 years as a screen onto which humans projected their imagination. Plants, atmospheres, civilizations, aliens, conspiracies. All of it, in the end, wrong. The actual far side is more interesting than any of the stories. It is older. It is harsher. It is a record of violence preserved for 4 billion years on the back of a rock that follows us through space. And it is about to become the most consequential 19 million square kilometers in the human future. Somewhere right now, the person who will be the first human to stand on the far side of the moon is alive. They are probably in their 20s or 30s. They are probably an astronaut, a taikonaut, or someone who will become one in the next 10 years. They might be Chinese, they might be American, they might be from a country that does not yet have a space program. The first person to set foot on Mars is also alive right now, and the first person to walk on the far side is, in all likelihood, going to get there first. We do not know who they are. We do not know what their name will be when they say the words that will be quoted in textbooks for centuries. But we know something about what they will see. When they step out of their lander, the sky above them will be black. Not the black of a moonless night on Earth. The black of space, untouched by atmosphere. The stars will be sharp, motionless, and extraordinarily bright. The Milky Way will arc across the sky in a band of light that no human eye has ever seen from a planetary surface with no atmosphere in the way. And the Earth will not be there. Every astronaut who has ever traveled beyond low Earth orbit, the 24 men who flew to the moon during Apollo, looked up at some point and saw the Earth. A blue marble, a thumbnail, a reminder of home. It was always there, hanging in the black, even when they were on the lunar surface. The Earth was a constant. The Earth was the orientation. The Earth was the way back. The first person on the far side will look up and see only stars. The Earth will be behind the moon, blocked by 3,475 kilometers of rock. For the first time in the history of human exploration, a person will be somewhere where home cannot be seen. Not because of distance. Mars astronauts will still see Earth as a bright star, but because the body they are standing on is in the way. We do not know what that will feel like. Buzz Aldrin, on the near side, called the lunar surface magnificent desolation. That is the most famous phrase ever spoken about the moon. It was said while looking at a landscape with the Earth hanging in the sky above it. The first phrase spoken from the far side will be said by someone looking at a landscape with the Earth gone. I suspect when it happens, it will become one of the most quoted sentences in the human language. I want to end by being honest because the popular version of the Far Side story is that science has it figured out, and science does not. We do not know why the two sides are so different. The four leading hypotheses are all plausible and all incomplete. We do not know what the mass anomaly beneath the South Pole-Aitken basin actually is, asteroid core or native lunar mineral concentration. The samples that would answer the question do not yet exist. We do not know the precise age of the basin itself, and that age calibrates the entire chronology of the inner solar system. If we are off by 100 million years, our models of when Mars was wet, when Earth was bombarded, when life could have begun, all shift. We do not know whether the lunar mantle on the far side is fundamentally different from the lunar mantle on the near side, or just locally different in the region we sampled. We do not know whether there are exotic volatiles, water, organics, ancient solar wind deposits, preserved in the permanently shadowed craters of the far side polar regions. We have indirect evidence. We do not have direct samples. We do not know whether humanity will manage to preserve the radio quiet of the far side, or whether the next 20 years of lunar industrialization will destroy the most valuable astronomical site in the solar system before we ever use it. We do not know who will set foot there first. We do not know what they will say. The dark side of the moon was never dark. It was the side of the nearest world to us that we could not see. For 4 billion years of geological history and 300,000 years of human history, it held its silence through the rise of every civilization that ever named it. It was photographed for the first time within the lifetime of people who are still alive. It was touched for the first time 6 years ago. It will be walked on by a human being almost certainly within the next 20. And here's the thing I want you to take away. The far side was not hidden because it was secret. It was hidden because of geometry. Because the same forces that locked the moon to the Earth also locked half of it away from us. Our ignorance was not a choice. It was a consequence of where we were standing. That is true of almost everything we do not know. Not just about the moon. About the universe. About each other. About ourselves. Most of what is hidden from us is not hidden on purpose. It is hidden by where we happen to be standing. The far side teaches a lesson that the near side cannot. The near side tells us what the moon looks like. The far side tells us what the moon is. The asymmetry between them, the thicker crust, the missing Maria, the buried mass, the silent sky, is the part of the story that the face we know cannot tell. For 4 billion years, the moon has been turning the same expression toward us. We have written poems to that face. We have named seas on it. We have walked on it. We have built our entire mythology of the moon out of the half that happens to point our way. The other half was always the more honest one. It kept the record. It took the hits. It preserved the evidence of the early solar system in a way the near side, repaved by its own volcanism, could not. It is the part of the moon that remembers. The face we see is the edited version. The face we don't see is the truth. Somewhere in the next 20 years, a human being is going to stand there. They are going to look up at a sky that contains no Earth. They are going to be, in the most literal sense possible, out of sight of every other person who has ever lived. What they do there, what they build, what they sample, what they protect, what they exploit, what they choose to leave undisturbed, will shape the next century of human presence in space. The far side, having spent 4 billion years as the quiet half of our nearest neighbor, is about to become the loudest part of the solar system. And almost no one is paying attention. The dark side of the moon was never dark. It was just